Welcome back to graphing trig functions. This is part 3, and we're going to look at something called phase shift. Now, phase shift just means the left or right shift. Okay, and we know how to do that. All we got to do is find our function. Okay, and within our function, wherever x is, we got to tack a little number onto it. And that's going to be what moves the graph to the right or the left, depending on whatever value turns the stuff in brackets to 0. So I'm going to jump right in with my first example. So let's see here. Let's clear the screen so I got a little bit more room. And our first example we're going to try to graph is this. We're going to do sine of x plus pi by 2. Okay, well, first things first. What changes is affecting x here? Well, what would turn this bracketed stuff into 0 would be negative pi by 2. So in other words, that's the amount of phase shift. I want to go pi by 2 to the left because it is a negative direction. So I think it's probably a good idea to give ourselves a little bit of a framework. I'm going to throw in the original graph without any changes, just as a sort of a light little dotted graph here. Just sort of frame it in, just so we can sort of see what we're doing here. Whoops. Doesn't matter. This is just my little framework anyway. Okay, so there's the original sine graph. And what we want to do is we want to bump the whole thing pi by 2 to the left. Now remember, this is pi by 2 here. So that means each little check mark here is the equivalent of pi by 2. So I'm going to put a little pi by 2 here. And so there it is. I just want to move everything over to the left. So I want to start here. Then when I go a quarter of the way into the cycle, I want to be, instead of here, I want to be here at my maximum. Then I want to be back down to 0. And then a quarter of the way, now I'm at my minimum. And then a quarter of the way after that, I should be finished the cycle. So let's see if we can get a decent picture here. All right, this doing it in sections is the key. If only I had known that all along. Anyway, looks like a pretty good graph here, and of course it keeps going. And there it is. There it is. There is this particular sine function, and has been bumped by pi by 2 to the left. Well, that's not too bad. You guessed it, I'm going to do another example, only this time I'm throwing a little more at you. Okay, so this time here's what I'm going to graph. Y equals, I'm going to put a number in front, and I'm going to use cosine here, then an x minus pi, and then a minus 1. So I got a little bit more stuff going on here. Now, you may want to rearrange it into implicit form. You could add the 1 over. So we could do this. And then I'm going to divide out that 2. So you may find that it's more familiar to you. So if I do that, here's what I have. Granted, I really have to cram this stuff in here. But anyway, all right, there it is. So you may want to do it that way. And then you could look and say, well, what am I doing to both x and y? The x is probably the least amount of stuff. All I'm doing here, it looks like a positive pi. So it really just means I'm moving the whole graph pi to the right. For y, I got a little bit more going on. First, I got to multiply it by 2, the y values, and then I got a minus 1, so it's like I'm moving the whole graph down 1 as well. So it's getting vertically stretched and it's being moved down by 1. All right, let's see if I got my grid here. See what I can do. There's my grid. it may be beneficial again to get a few comparison points here. So I might just list the old points. And for cosine, it was 0, 1. And then we had, you know what? I'm just going to do the main points here. I'm just going to do kind of I won't bother with every little point, but just enough to kind of help guide us a bit. Let's see, cosine went to -1 at pi, and then when we finished the cycle at 2 pi, we were back at 1. So those are sort of the old points. Now the new versions of those guys. All right, well the x's are easy enough. I'm just adding pi to all these. So this is going to be pi, and then this is going to be 2 pi, and then this is going to be 3 pi. So that's not too bad. The y values, what am I doing? I'm timesing by 2, so this is now 2, but then I got a -1, so it's 1. Oh, and look, I got the same y value down here, so that's also going to be 1. So yeah, it's funny that those ones haven't really changed in the end. Okay, what about this guy? Multiply it by 2, and you get -2. When you -1, it's at -3. So that's going to show us the biggest change. All right, so to frame this whole thing in, I've got to get all the way over to 3 pi. So let's see, I better go pi, 2 pi, and 3 pi. Okay, so this gives me those points. And I might put the little markings in between for a little greater accuracy. And then as far as my y scale, I got to be up to 1, but also down to -3. So let's call this 1. And then we'll go -1, -2, -3. Okay, so what a lot of students like to do to get a more accurate drawing is they kind of frame it in. You know, they'll put a little light line across the top here to say, okay, nothing goes above that line and nothing goes below this line. Okay, it just kind of frames your oscillations in. So you know it's all between those two lines. And we know we want to start everything at pi, right? So what they do is they just put a little mark down like this. Kind of, as I say, it kind of frames it in, and we want to end it at 3 pi. So you go, okay, that's where I'm going to draw in this little sort of rectangular framework. I'm going to draw the cosine graph, and I know I'm starting up here, and I know I'm ending up there. I know halfway through, so let's see, 1, 2, 3, 4. Yeah, halfway through is 2 pi. I'm down here. Halfway between these two guys, I got to be at the median, which means I got to be halfway between 1 and -3, and that would be at -1. So that's where this guy is. And same thing between the minimum and the maximum over here. So I kind of got my key points all framed in, and now let's see if I can draw this. All right. Okay, a moment of silence for the drawing. All right. Hey, that's all right. I can live with that. Okay, there it is. So we have graphed it, and I am going to return, and I'm going to be doing more examples of these full meal deals. Now we haven't really done any where we changed the period a whole lot in conjunction with other transformations, but you can bet that is coming up. So I am going to stop for now.